Welcome to Hosokawa's Expert Talks. Today we are going to talk about Hosokawa technologies used in the battery industry.
Powder processing technology plays an important role in the battery production. Today we will tell you something about the role Hosokawa can play in this type of industry. We will not focus on all the details, but want to give you a brief overview of the possibilities of Hosokawa. I would like to give the word to Dr. Dion Spink.
Thank you, Alet. And I will start out by briefly explaining what a battery is and does. The most important battery type is the lithium-ion battery type, and this one contains a cathode, which consists of a lithium metal salt, and an anode, which consists of graphite. And during the discharge of a battery, the lithium hops from the cathode to the anode, and the electron cannot do that, and it has to move from the current collector to the other one over a wire, and this is what's producing electricity. During the charge of the battery, the process is reversed. So the lithium ion hops back from the anode to the cathode, and the current goes the other way. All raw materials for a battery start out in a mine, both the metals in the cathode and the graphite in the anode. And then they're made into the battery precursors. And in this process there are some steps involved, and after the precursors are made into sheets on the current collectors before they can be assembled to the batteries. And we're going to explain you in which parts of this process we can provide solutions for you. We start out with the production of NMC, which is a common cathode material. NMC consists of lithium with manganese, nickel and cobalt embedded in its structure. And the production is started by mixing the nickel, manganese and cobalt in a tank reactor. After this they are precipitated, and the filter cake is filtered and the water is extracted, after which the cake is dried and milled before it can be mixed with lithium and sintered to the final precursor, which is NMC.
So drying is one of the first processes Hosokawa gets involved in the battery industry. For continuous drying of, for example, precursor material, we use our flash dryer. The product, a filter cake or a slurry, will fall into the drying chamber where we have a dispersion disc. And the dispersion disc is making sure that the larger agglomerates in the feed material will fall into smaller particles, creating a high surface area which is sufficient for drying. We dry up to about 1% of end moisture. If we need to achieve lower moisture contents, we can make use of our batch dryer. We also can use it for smaller production capacities. We have a vacuum dryer, the Nauta dryer, or the central pedal dryer, which can also operate at higher temperatures. The temperatures of 325 degrees C in combination with full vacuum is ensuring that also the difficult volatiles will be evaporated, and we can go to ppm levels. In order to increase the efficiency of a battery, it's important to have a well-defined particle size distribution and small particles. It makes it easier for lithium ions to travel from the anode to the cathode and back, as Dion already did explain. Ultrafine powders, like for example lithium cobalt oxide, will result in improved battery performance, achieving for example higher usable capacity or faster charging rates. Who doesn't want to have a faster charging rate? Hosokawa uses dedicated impact and jet mills in special execution in order to produce extremely fine and a narrow particle size distribution. Top sizes are 10 to 25 microns and a D50 of 4 to 15 microns, depending of course on the product. All mills do include special designs against wear protection with ceramic. This ensures a high purity of your product. In the anode, active material is graphite. Graphite can be either of a synthetic or a natural type. Jet mills can be used for grinding both types of graphite. Spheroidizing can enhance the density and the wettability of the graphite. Synthetic graphite is usually already more spherical after grinding and therefore requires less energy for rounding. Natural graphite is plate-shaped and therefore it will be more difficult and more energy is required in order to get around the particle. Hosokawa has for both types of graphite rounding solutions. Dion, can you explain the step after drying and milling?
After drying and milling, when the precursors are produced, it is important to coat them with carbon black to improve the conductivity and to coat them with binders to improve the adhesion. And for this, it's very important that they are coated very well on the surface of the precursor. And if we mix them only with an impact mixer, then there's a very loose coating around the precursor particles. While if we mix with high shear, the particles coat very well, or even are even embedded in the precursor material. This creates a very strong bond between the carbon black and the precursor, which yields very good batteries. After this step, the precursor with the carbon black and the binder are dispersed in NMP before they can be coated onto the current collector and they can be dried. After that, the battery is ready for assembly.
In the battery production process, a lot of powders are being mixed. For example, low shear mixes are being used for homogenization or for an agitated feed hopper. Besides powders, the Nauta is also capable of mixing slurries. However, in most processes, the battery industry requires more energy. The raw materials are prepared and they have a good particle size distribution and a very small particles. The particles give a high surface area which is beneficial for our battery. However, it also gives an annoying behavior. The particles act like best friends forever. They are bonding to each other. In order to create a good mixture and to create a coating, this bonding needs to be destroyed. For this we need to have high shear mixes. In our portfolio we have high shear mixes and ultra high shear mixes, like the Cyclomix and the Modulo Mix, which is the continuous Cyclomix, the Nobilta and the Mechanofusion. All these units can be foreseen with a wear resistance coating in order to avoid pollution in your products. Hosokawa has also lab equipment for the battery industry. For example, the Mini Cyclomix and the Cyclomix 5 liters, the Picoline for milling, classifying and mixing, and the multi-processing unit. So Hosokawa can cover the whole range from lab to pilot to full production. And last but not least, safety first. Of course, all our equipment can be delivered with ATEX certifications. However, a lot of materials used in the battery industry are not the most friendly. So we need to protect the surroundings and operators in one way or the other. The Hosokawa has several solutions for that. So, for example, personal protection, which is not part of the Hosokawa supply, but a downflow booth can be used in order to obtain OAB levels of OAB 3 or 4. Split butterfly valves can be used for OAB levels 4 or isolators to go to OAB levels 5. So, we have given you a brief overview of the capabilities of Hosokawa in helping you with the challenges in the battery industry. Hosokawa can help you with drying, milling, grinding, classification, rounding, mixing, coating and embedment, containment, and we have from lab scale to pilot scale to full industrial scale equipment. So, thank you for watching. We hope we did charge your battery and talk to you soon.